Hi, my name is Mehek, and I'm the project manager for HyperExcite this year. I'm a part of the management team, and I'm personally responsible for managing the team finances and sponsorship package, finding sources of funding for the project, defining and managing the project and team goals and timeline, acting as project liaison between the team and our faculty advisor, Professor Roger Rangel, and outside entities, and finally, assisting the pneumatic system.
Hello, my name is Nathan Bernardo, and I'm a fourth-year electrical engineer, and I'm part of the management team for HyperExcite. So as part of the management team, I manage both the powers and the control systems, and essentially they are responsible for designing the powertrain and the logic controller for our Hyperloop pod. Coming into the team as a systems engineer during the summer, I knew it was going to be a challenge since we all had to work remotely, but we were able to design our logic controller as well as our printed circuit board for the powertrain as well as the low voltage devices. So that is a great accomplishment for all of us.
Hi, my name is Martin Fan, and I'm the chief engineer of HyperExcite. I work in the management team, and I work with the project manager and our electronic systems engineer. And our primary responsibilities, or I guess my primary responsibilities, is that I generally do design reviews of the technical side of things. So I work with our propulsion systems, our stabilization systems, braking, and stuff like that. And I just generally have the biggest oversight in what goes into the pod, how do we test it, how do we simulate these things. So those are my responsibilities.
Starting this year, we are implementing ValleySpace, a project management tool that will allow us to keep track of project progress and assist with subsystem integration.
Some of the tools I use for organizing and managing all the tasks as well as the deadlines is ValleySpace and GitHub, which are really great for just making sure I'm following everyone's tasks as well as keeping all the documentation for next year's team.
And as for the softwares that I use, I primarily use SolidWorks, and I don't do much CAD myself. Generally, I just use SolidWorks just to review other people's design and see if any assemblies are broken or anything. But other than that, that's pretty much all I use.
Because we are working remotely, we've had to come up with creative team bonding activities, and they've been surprisingly effective and fun. A goal of the management team this year was to have a team that works well together, and we've been able to achieve that with our activities and great communication. This year has been unusual, considering that we have to operate remotely, create new project goals as there is no SpaceX Hyperloop competition this summer, and have limited access to the lab on campus. Over the summer, we participated in a Hyperloop symposium, publishing a research paper, and are now preparing for the European Hyperloop Week conference and competition occurring this summer.
Thank you for watching.
Hello, my name is Lana Ha, and I am the braking subsystem lead. In terms of the role of the braking subsystem, it's kind of in the name. We interact with the flanges of the I-beam track in order to provide braking force to the pod and eventually bring it to a stop. As a subsystem lead, it's my job to ensure that our system is on track with the project timeline, and I interact with other subsystems to properly interface our design with the rest of the pod. I also help with the design side of the braking subsystem.
Hello, my name is Vikram, and I'm part of the braking subteam. My role on the team is to build CAD models of the braking test rig, do calculations and simulations to test the performance of our braking system, and hopefully manufacture the pod as soon as possible.
Hello, my name is Rahul Shet, and my role on the braking subsystem is to design different parts that we need to develop our braking subsystem, as well as conduct simulations on the braking subsystem to simulate what the what the system would look like while it's actually braking. Some of my responsibilities were to design a braking test rig, which is basically a device that would help us test and measure the braking force that is produced by our system.
We use SolidWorks to build CAD models and ANSYS to perform simulations on individual components. However, everybody on the team has been extremely helpful and cooperative, which has made working on HyperXSite extremely fun and engaging.
I believe that everyone on this team has very good communication with one another, and hopefully in the future we will be able to go back into the lab and keep working.
So this year has definitely been challenging. There's been a departure from previous years as we've moved to a mostly virtual format. However, I believe that our team has adapted fairly well. We can still work on design together, we can still exchange ideas, it's just through a screen rather than in person.
Thank you for watching.
Hi, I'm David Villapando, and I'm the lead for the Dynamic Subsystem on the ECI HyperXSite team. The role of the Dynamic Subsystem is to manage all interactions between the pod and the track. This requires designing and developing propulsion systems to take the pod from rest to maximum velocity, as well as multiple stabilization systems that will provide a smooth run. As a subsystem lead, my responsibilities are to assign tasks to myself and my fellow members and ensure that the design and manufacture of the dynamic system proceeds smoothly, as well as to work with the other subsystems in order to integrate the dynamic systems with the pod.
Hi guys, my name is Bobby Lavger and I am part of the Dynamic Subsystem. My specific role is as the vibrations engineer. As the vibrations engineer, my work focuses mainly on ensuring pod stability during travel. The Hyperloop concept involves a monorail, and in our case, it is a steel I-beam, which is standard to the SpaceX competition. A monorail requires more stability than a car, for example, because it has more degrees of freedom. I am responsible for selecting and analyzing our individual springs and dampers for our 12 stabilization units. As a result of our pod having wheels, we have 12 contact points with the I-beam, which corresponds to the 12 stabilization units that we have.
Hello, I'm Christine and I'm part of the Dynamic System subteam. I help design the propulsion and the underside stabilization units for the pod.
Hi, my name is Christopher Wu and I'm part of the Dynamic Subsystem. So far, my individual role within the team has been to help design the propulsion units for our pod, as well as select the necessary springs and dampers for our suspension. To design the propulsion units, our team used SolidWorks, and in order to select our suspension, MATLAB will be used to write a script that outputs spring parameters based off a given design by calculating to the system's equivalent stiffness.
Let's just address the elephant in the room. The pandemic, it has affected all projects, even HyperXSite. Despite having to work remotely, all of our work has been completed, and it hasn't affected our design and our earlier analysis very much. Of course, we want to be able to be back in the lab, but I'm proud of what the team has accomplished despite the challenge. Thank you. Thank you for watching.
In the piping and cooling subsystem, we depressurize air to send it to the actuators in the braking system to be able to brake the pod when it is going at higher speeds.
My individual role on the team is to design and implement the piping and cooling subsystem. This year, this has taken the form of a lot of assembly, integration, and testing within the lab. And testing is very important for the piping and cooling subsystem because when it comes time to test the pod, we must be 100% certain that the pod will come to a safe stop. So fault testing each of our components, leak testing each of our components, and making sure that everything meets the factor of safety that is set by the competition guidelines.
My role on the piping and cooling subsystem is a thermal systems analysis engineer. In this role, I'm participating in designing, manufacturing, and testing the pneumatic system. The programs that we use on the piping and cooling subsystem include SolidWorks and ANSYS. The year has been kind of a struggle with COVID, but we have been able to get our design finalized. But moving into the manufacturing phase, we have struggled to be able to go into the lab and start putting our components together to see the final product.
Thank you for watching.
Hi, my name is Nicholas Nebite. I'm part of the UCI Hyper site. I'm on static structures. Our role is to create and design and build the chassis, the fairing, and mounting solutions for everybody else's subsystems, like dynamics and power systems, pneumatics, so that they can put their components onto the pod effectively.
Hi everybody, my name is Danny Nguyen, and I am a part of the static structures subsystem. My individual responsibility isn't one specific thing, but if I had to pinpoint, I believe that it's being in charge of carbon fiber and manufacturing of the fairing.
And then my individual responsibility, I do a lot of CAD modeling and 3D design, as well as when the time comes, I will be manufacturing a lot of components for the pod.
Hi, my name is Tyler Johnson and I'm in the static structures subsystem. I personally use SolidWorks for getting dimensions and prototyping, and use ANSYS to simulate the forces on the chassis mold and test the aerodynamics of the fairing, using simulations like CFDs and FEA. It's been a pretty tough year considering the lack of access to the lab and the ability to manufacture the fairing has gone down dramatically. When we begin manufacturing, we'll be using a carbon fiber layer process using a female mold and a vacuum to get all of the layers even. We will have to experiment with leftover materials to gain a certain level of competency with the procedure to make sure we don't waste a ton of carbon fiber in time.
Thank you for watching.
Hi, my name is Beverly Ortiz Ramirez. I am a third-year electrical engineering major and I am part of the power subsystem. Our role on the team is to integrate electronic components on the pod in a high voltage and low voltage system design. Our high voltage system integrates our motors and ESCs safely, while our low voltage system integrates all other components such as MCUs and sensors. Some of our responsibilities include designing circuits, creating and manufacturing a PCB, testing, optimizing, and working closely with the controls team to ensure a working product.
Hi, my name is Sophia Riazi. I am a fourth-year electrical engineering student, and I am a power systems engineer for the powers team on HyperX site. Over the summer, my team and I designed the low voltage system PCB and manufactured it in the fall and began starting components onto it in lab. We also have a preliminary design for the high voltage system, which consists of a pre-charged circuit and will be manufactured and assembled in lab as well. The powers team uses several software programs. We use Altium to design our PCBs, OrCAD capture CIS for circuit analysis, and ANSYS for thermal simulations. However, due to COVID-19 related campus restrictions, work on the physical PCB has been paused indefinitely. These next few months will be dedicated to research and development. Currently, we are working to enhance our design for both voltage systems, particularly looking into ways we can improve power and thermal efficiency on our PCB. In addition, we'll be working closely with the control subsystem to create a test environment where we can simulate our designs.
Thank you for watching.
Hi, my name is Muhammad Khalifa, and I am a fourth year studying computer science and engineering, and I'm on the control sub-team. The control sub-team's role is to devise an embedded system that will control the pod using different sensors and ensuring the safe operation of the pod. In addition, we work on creating an interface that would allow us to monitor the pod state while also enabling remote control. Some of our responsibilities include choosing the microcontrollers and sensors that would allow us to control the pod, integrating them on the software and hardware level, implementing the finite state machine that would navigate the pod, testing all our components, and working with power systems closely to make sure that we have a correct and concurrent design.
My name is Adrian Ornelas, and I am a first-year engineering student. In order to create the software and hardware that our team relies on, we've had to use several different programs and technologies. In brief, our main microcontrollers are the Raspberry Pi 4 and the ESP32. Of the various software we use, the most prominent are the programming languages Python and C, and our preferred development environment is Visual Studio Code. However, we are not limited to just these, as we have to interface with a wide variety of devices from several different manufacturers in order to create a cohesive system for the pod as a whole. This year has been a challenge because of the pandemic. However, in spite of all of the obstacles, we have been able to create meaningful progress in designing and developing the software for the pod.
Thank you for watching.